of these problems have a very similar general setting. Okay, most of them rely on that normal table, which if you don't have your table out, go ahead and get that out. If I give you the z value, then you're just reading from the table. If I give you an x value, we first have to convert it to a z. So we know that z is your x minus your mu over sigma. Then we've also done this with x bars and p hats. So really we've done the same thing. At the beginning I just said z equals this and you read it. Then I start giving you an x value and you have to change it into a z. And then we've done the same thing with both the x bar and the p hat. What you have to pay attention to in your problem is, what am I finding this for? Like if I look at problem number 4 on here. Problem number 4 has z values. So what do you do if I give you the z values? You go straight to the table. Now when you get to problem number 6, this is talking about the probability that a student has a particular score. If I'm just talking about one person's score, is that an x bar, or a p hat? That's just your x. So when you have the x value, you're using the mean and standard deviation for the entire sample. When we look at number 7, I just want the probability of more than 50. Between these, are those x bar, or p hats? What is x bar? You guys can answer that. What is x bar? Sample mean. Okay, so you use the x bar. A big indicator would be if I have an x bar in your problem, or if I say the word sample mean. If on problem 7, is there any mention about the sample mean, or finding the probability that the mean is more than 50, or the mean is between these things? That's just the mean of the entire thing. So I don't mention the actual sample mean, so it's just an x. What's p hat represent? That's sample proportion. When you look at it, it will be a decimal. It's like a probability. So I might give you a percent. I might give you the decimal like 0.5, 0.46. It'll be something smaller than 1. It is a proportion, so like a percent. All right, so the big thing here when looking at these problems is just being able to figure out, what am I talking about? Am I talking about an x bar, or a p hat? The setup is the same, but when I'm talking about the different variables, your sigma and your mu change. If my problem is talking about x bar, then when you find your z, you're doing your x bar minus the mean of your x bar over the sigma of your x bar. If I'm talking about your p hat, your z is the p hat minus the mean of your p hat divided by the standard deviation of your p hat. So you have to watch so you know what mean and standard deviation to do. Does that make sense to everybody? In talking about the x bars and the p hats, we also have a couple criteria. These are not on your formula sheet, so you have to know it. For x bar, you need either the original data to be normal, or what has to be true? If I say it's normal, or if your n is greater than or equal to 30, we can assume it's normal. So when I say describe the sampling distribution for x bar, I'm asking you to mention that criteria. Either saying, okay, it's already normal, or, oh, my sample is bigger than 30, so it's going to be normal. When I'm talking about p hat, my criteria for that, I have 2. Your n times p times 1 minus p is greater than or equal to 10, and the sample has to be less than 5% of the entire population. So you need to know, those are the pieces that are not written on your formula sheet anywhere, you just need to know them. Almost everything else is directly off our formula sheet. So it's just a matter of making sure you're plugging it in the right spot. One other thing, what does it mean if I say it's something unusual? Probability less than 5%. Okay. So let's start looking at your questions. On the first page, the only question that you guys brought up was the interpretation. So when you are interpreting the normal values, so this is kind of like problem 3B. There are two options for what this might mean. You can think of it as a proportion, or you can think of it as a probability. So for the proportion, for 3B, if I gave you that number, we are talking about the probability that the miles per gallon fell between those two numbers. It could mean the proportion of motorcycles with the miles per gallon between those numbers is the 0.6419. So if I found all the motorcycles in my sample and took the ones with the mileage between those numbers, I would get 0.6419. That's thinking it as a proportion. Thinking of it as a probability is saying the probability a random motorcycle has a mileage between 29.3 and 23.7 is that. So it can be talking about the probability that a particular one will be, or the proportion of all of them. You can expect me to ask you that somewhere on the test. Just making sure that we understand what these numbers could mean. So it's either the probability or the proportion. Are there questions on that? What about number 5 with the Z alpha? That has been something we have struggled with. Are we okay there? We need to look at it? I don't think real quick. So we touched on Z alpha at the beginning, and then we were using it again at that last section. What this says, the alpha is area to the right. We know the middle of this represents the 50%. So if the area to the right is 0.34, it's definitely got to be on this side. That is 0.34. So the table, our normal table gives us area to the left. So we have to think, okay, my area to the left would be 1 minus 0.34, which is 0.66. So in your table, you are finding when the probability is 0.66. So you go to your normal table, you are finding the 0.66 inside, because it's the probability. You need to give me the Z value. So you find your 0.66, or as close as we can get to it, which is 0.6591. And the corresponding Z value then from the outside is 0.41. All right, are there questions on that? Okay, so moving on. 6, 7, and 8, you guys did okay on all of those? So problem 8 was where we switched to the X bars in there. So then looking at problem 10. It tells me, let's see, 22.4% of adults are smokers. We have a random sample of 300 adults. Okay, this is a percent. What did I tell you? If I'm giving you percents, what am I talking about? P hat. If you look, part A kind of gives it away too. It says describe the sampling distribution of P hat. So for P hat, describe the sampling distribution. You have to check the criteria, mean, and standard deviation. So the first criteria, your N times P, you have to change that to 0.224, 1 minus P, has to be greater than or equal to 10. So if I do that, that's 52.1472, so that is most definitely greater than or equal. Second criteria, your sample has to be less than 5% of the entire population. Would 300 be less than 5% of all adult Americans? Don't just tell me, like on part A, don't just say N times P times 1 minus P is greater than 10. Actually show me that you're working it out and double checking it. So now we need to find our mean and standard deviation. This is where the formula sheet is really handy, guys. All of this stuff now is on there. If you look, your P hats, it tells you, let's see, on chapter 8, right hand side, it tells you your mean is just your P value, which is 0.224. Your sigma is the square root of P times 1 minus P over N. So if I work that out, try to keep a few decimal places here. What is my N? I don't know why I wrote N instead of the number. 300. And we get 0.02407. Okay, so that's all for part A, describing the sampling distribution. Now we know we're using P hats. A problem I saw on the last quiz was you guys would go through this, but then mainly on the X bar problems, you would go back and use the mean and standard deviation given in the problem. If I am finding probabilities according to P hat, then these are the mean and standard deviation that I'm going to be using from here on out. So part B wants the probability that at least 50 are smokers. Now, these are P hats. P hat is a proportion. So how do I change 50 into a proportion? So my P hat, X over N, so 50 over 300, and that gives me 0.16. And I want the probability that at least, so greater than or equal to 0.1667. It really helps. Some of you like to show as little work as possible, but it really helps you to organize yourself if you kind of write out these steps. Show me your P hat, show me we're finding probability that it's greater than. So now we need to convert this to a Z. So you do your P hat minus the mean divided by the standard deviation for P hat. Okay, if you divide those, we get Z greater than or equal to one thing that might be different, kind of depending on how many decimal places you have used, you might get slightly different answers. They will not be different by a lot, but slight differences. So I need to have work so I know how you are getting your answer. Since this is my z, I only need 2 decimal places here. Greater than means we do what? 1 minus, then you go to your normal table. You look up negative 2.38. Make sure you're following along with me. Even if you get it right, it doesn't hurt to review it. And we get 0.9913. Part C. Would it be unusual if 18% or less were smokers? So I'm asking for the probability. If I'm talking about a percent, I'm talking about p hat. So p hat is less than or equal to, for 18% you have to do 0.18. So change it to a z. If you plug that in, we get z is less than or equal to less than, you just read from the table, so you go to negative 1.83 and it tells you 0.0336. I asked if that was unusual. Unusual means less than 5%, so is this? Yes. Are we okay with number 10? Number 11. So this one, again, it's talking about an N. We have a population, and I tell you that your P is 0.63. So we are back to the P hats again here. Part A describes the sampling distribution of P hats. So show me the work on this. N is 200. P is 0.63, 1 minus P. So if you plug that in, you get 46.62. That had to be greater than or equal to 10, so that works. Second one, we actually need to check. You can't just tell me it's less than 5% of the population this time. You need to check it. We need 200 to be less than or equal to 5% of the entire population, which is 32,000. So 0.05 times 32,000 gives us 1,600. And is 200 less than or equal to 1,600? Yes, so the criteria are met. Then your mean for p hat is just your p-value, which was 0.63. Sigma for p hat, square root of p times 1 minus p over n, which was 200. You get 0.034139. There's a reason we just calculated this. From here on out, when I talk about a mean or a standard deviation, I'm using these. Part B. I want the probability of obtaining 141 or more. Now you could find your P. You just do your 141 out of 200 to get your P. I actually gave it to you though. I'm finding the probability that P hat is greater than or equal to 0.705. So change that to a Z. So plug that in, and you get the probability that Z is greater than or equal to 2.196, so 2.20. Greater than means 1 minus. Go to your table. When Z is 2.2, what do you get?
0.9.
And That should give us 0.013. Part C, the probability of obtaining 121 or fewer. What do I have to do first?
You have to like make it.
Yeah. It's 121 out of my 200. So that means my p hat is 0.605. I want that many or fewer, so less than or equal to 0.605. So that's probably that Z is less than or equal to 0.605 minus your mean, which we're using the 0.63, over the standard deviation. So if you plug that in, you get the probability that Z is less than or equal to negative 0.73, less than you just read from the table. And that gives you 0.2327. I failed to talk about 9B, didn't I? Skipped one. I'll go back to it. Are we okay with those questions? Okay, we had a question on 9B and I skipped that one, so let's go back to it. Real quick let's talk about 9A. This one tells me to describe sampling distribution for X bar. What's the criteria for X bar? Right. Either I have to tell you that the population is normal, which I did not, or your n has to be greater than 30. So n is bigger than 30 here, which means it is normal. Your mean for X bar is the same as the mean of the population, which is 64. Sigma for X bar is the standard deviation of the population divided by the square root of n. So you get 3. Now, in part B, I am now talking about X bar, so I'm using this mean and standard deviation. I want the probability that X bar is less than 62.6. So change it to a Z. So 62.6 minus the mean for X bar is 64. Divided by the standard deviation for X bar is 3. So if you divide those, what do you get? Less than you read from the table. So you just go into your table. Negative 0.47 gives us 0.319. Are there any others on problem 9 that we need to look at? On D, you guys remember how to do the probability that's between two things, don't you? You find each of their individual probabilities and subtract them. Do we need to look at number 12, the confidence interval? Okay. Alright, it says, construct a 98% confidence interval for the population proportion. Population proportion means what? P hat. Go to your table or your formula sheet. So confidence intervals. Under chapter 9, it's got a confidence intervals. You have two options. We just established that we are looking for P hat. So this is our formula. Okay, so we need all of our information to plug into there. P hat. If you're not sure, if you look right above chapter 9, it tells you sample proportion. P hat equals x over n. So my x is 80, my n is 200. If I divide those, we get 0.4. Z alpha over 2. 98%. Okay, so 1 minus 0.98 is 0.02. divided by 2 is 0.01. What that means, that's our alpha notation. So there's 1% to the right, which means 99% is to the left. So you go to your table, looking inside the table, you're trying to find the closest you can get to 0.99. And that is 2.33. Remember, I did tell you some of those are given at the bottom, but not all. 98%, that is on there, but you can expect me to ask at least one on your test that is not on there, just to make sure you know how to read from the table. Then, I already know everything else, so now we can plug in. 0.4 plus or minus 2.33, square root of 0.4, 1 minus 0.4, over the n was 200. So you just plug in one at a time, so if I do 0.4 minus that, we get 0.3193. And then if you just hit second enter, you can change your minus to a plus, and you get 0.4807. So the interpretation there, if I ask for it, we are 98% confident that he has, so the sample proportion is between those two numbers. Let's talk about 14. A school administrator wants to estimate the percentage of full-time college students who have credit card debt of $2,000 or more. What sample size should be obtained? Right there. Stop for a second. I said what sample size. So where are you looking on your formula sheet?
On the sample size.
Yeah, where it says sample size. Okay. Should be obtained if she wishes to estimate within 2.5 percentage points with 94% confidence. All right, so part A, we are talking about the pilot study indicates the percentage is 34%. On this, you are either estimating the sample size for the population proportion or population mean. If I'm talking about the percentage of students, is that a proportion or a mean? Proportion. So you have two options for formulas in the sample proportion. Part A, I am giving you a percentage to use. So that is the first one, when we have a p-hat based on like a pilot study or some earlier data. Okay, the p-hat here is the 0.34. It said 94% confidence. Is that one given on your table? No. So let's figure out our Z alpha over 2. What is alpha? .06 because 94, 1 minus 0.94, 0.06. Divide that by 2 and that's 0.03. So that's the area to the right. Area to the left then is 0.97. This one is not on the bottom of the table. I want everybody looking right now. You are finding the 97% inside the table. So looking on the inside, look for 0.97. And the closest we get, 1.88. You can expect at least once, if not more than that, to have to look that up on the test. So that is my Z value. What is my error? Right, I said within 2.5 percentage points, so error is 0.025. So now we plug this in. On these, you always have to round up. You get n to be 1,268.99. So you always, no matter what the decimal is, round up to the next whole numbers. So we need 1,269 people. On part B, if there is no prior estimate, that means you are using the second version. So that is your, the Z alpha over 2 is still 1.8. Error is still 0.025. This time when you plug that in, you get, so round that up, 1,414 people. Okay. Let's look at 15C real quick. I'm just asking you to find the T value. When I say T, what should you do? Yeah, look at the T table. It's on the back of the normal chart. All right, 96% confidence with 23 degrees of freedom. Remember, this is just kind of like the Z. We're talking about alpha over 2. So 96, what's my alpha?
0.02.
So I'm looking at my T of 0.02. If I tell you the degrees of freedom, that's when you just look for it on the table. So at the top, your percent should be 0.02. Then you go to 23, and those match up at 2.177. If I didn't give you the degrees of freedom, if I gave you N, how do you find your degrees of freedom? So if I said we had like 27 in the sample, that would be 26 degrees of freedom. Okay. Problem 17. So a survey asking 40 Americans how many books they read per year found that X bar is 13.4, S is 16.6, and we just know our N is 40. Construct and interpret a 99% confidence interval. So, looking at your confidence interval section on your formula sheet, we're talking about X bar, so your confidence interval for X bar. This one involves the T's. We know the X bar. All right, I need my T alpha over 2. So, it was 99% confidence. So what is my alpha? So 0.01 over 2 is 0.005. What is my degrees of freedom? Okay, so you're going to go to your T table, 0.005 and 39 degrees of freedom, and you get 2.708. So we have X bar plus 2.708 times S over the square root. You use N here. It's not the degrees of freedom. It is just your N value. And then you should get your window. Yes, ma'am.
How did you know when to do just the degrees of freedom and then when to do 1 minus it?
On 15, it said with so many degrees of freedom. So if I give you that, that's the number you use. On 17, I did not say degrees of freedom. I just told you N. So that's when you do N minus 1. Other questions? You're supposed to interpret this too. So we're 99% confident the mean is between these values. So